determines y is full dependent. If we remove any of the attribute, it should not be hold anymore. The some other dependency should not hold anymore. At last, that is should be a last dependency. That we say it as a fully functional dependency. Example, let's just take example here. This is the table we have given: employee project, SSN, phone number, hours, e-name, p-name, and p-location. These are the attributes, right, for the employee project. They have combined two tables here. One is employee table they have combined, and the project table they have combined, right? And SSN and p number, they made these two as a primary key, right? So combination of these two, nothing but, if you just consider this is the x value and ours is the y value. This is the set of attribute value for the x determinant, right? And ours is the y determinant, correct? So SSN and p number, these two, combination of these two become nothing but x value is a set of attribute. So what it says, the combination of SSN and p number determines ours. The combination of these two, nothing but SSN and p number determines ours. This is functional dependency 1. Means this hour is fully dependent on these two attributes, SSN and phone number. This attribute hour, that is y attribute, is fully dependent on the SSN and the phone number. This is functional dependency 1. You just taken they just given an example, a functional dependency 1. In FD2, you just observe here that only the SSN is dependent on the e-name. Means x attribute value is only SSN and y attribute only e-name. Correct? So SSN is determined by e-name, but the combination of these two is the value for this table. This to becomes the primary key for this employee project. Means this e-name is partially dependent on the SSN, because with the help of p number, with the help of project number, we can't find out e-name. With the help of project number, we can't find out the e-name, because this e-name only for second determinant, only the given SSN has determined with the e-name. So this e-name is what? This e-name holds partial dependent. It is not a full dependent, but our is fully dependent, because this table is having two primary keys. This our can easily find out with the help of these two primary keys. That's why we can say our is a full functional dependency. So what we have to make, if the table is having a partial dependent, this e-name is a partial dependent, because this is only determining by the one prime number, primary key of this table, employee project, it is primary key SSN, but not the p number. The same way, the third functional dependency example, just observe here, p number. P number, this is the only one primary key determining p name and the p location. So we can easily say that p name and p location is partially dependent on the p number, and e name is partially dependent on the SSN, but our is fully functionally dependent on the PSSN and the p number, because it is combining, it is determining by both primary key, the whole primary key of this table. But for other attribute, only the single primary key is what determining the attribute. So if we have like this in the table, we have to apply second normal form. Before applying second normal form, this table should hold the first normal form. Means each value in this table should not have a multiple value, right? And composite attribute. Before applying second normal form, we have to check whether the table is in a first normal form or not. If it is in first normal form, then only we can apply it on second normal form. Otherwise, first we have to apply the first normal form, then we have to apply the second normal form, right? The second normal form says that each attribute should hold a fully functional dependency. If any of the attribute is not fully functional dependency, if it is a partial dependency, then we have to apply second normal form. How to apply second normal form? Just we have to decompose, and we're going to split this whole table into number of tables depending upon the determinant, depending upon the dependency. Here, by this table, we're going to decompose. We're going to split this table into three tables. Why? Because we have three functional dependencies here. One is full functional dependency, and other two are having a partial dependency. So one table should have a functional dependency, full functional dependency, and we have to create other attribute which is acting as a partial dependency. We have to make it as a full functional dependency. How? We're going to split this table into number of other tables, right? How we're going to split the table? See here, SSN and phone number, hours. This is the main table they have given. We're going to apply the second normalization here. For we're just giving a new name, employee project 1, SSN, P number, hour. The combination of these three becomes the what? One table, because this is acting as a full functional dependency. So SSN, P number, hours. Next, separate table employee 2, because e name is acting as a partial dependency for on this table. So what we're going to do? We're going to split this table, right? So we are just making this primary key, because this is by SSN only you're going to determine the e name. So we made this table, this SSN only as the primary key to the second table employee 2. Now this becomes, this employee's e name has becomes the fully functional dependent, because in this table we don't have p number as acting as another primary key. That's why we're going to say this employee 2, employee project 2 is acting as a full functional dependency. Earlier in the previous table it was partial. After splitting, we're going to combine with the found primary key. Then now it is a fully functional dependency. Now the employee 3 here, p number, right? P number, it is going to determine the p name and the p location. So split this table into, to make it as a fully functional dependency, you just give the name employee project 3, p number, p name, p location. So this becomes what? A fully functional dependent, because p name and p location are going to determine with the help of this p number. This is what the fully functional dependency. So earlier previous table it's having a partial dependency. By applying second normal form, we're going to divide the table into number of tables, and each table should achieve the second normal form by making each table as a fully functional dependency. That is what second normal form says. Second normal form is of we have to achieve the full functional dependency. If the table is having partial dependency, we have to split the table and we make each table as a full functional dependency. That is what second normal form says.